Hello friends, today we will discuss about some more problem related to Kirchhoff voltage law and Kirchhoff current law. These problems are from previous year GATE and IES exam. So let's start. Suppose this number 4 problem, this problem. You see, this is a 200 volt DC source. This is a resistance R, and this resistance is 24 ohm, and this resistance are 8 ohm. And the voltage difference between these two nodes is 24 volt. You have to calculate the value of resistance R. Now, this resistance are node. So suppose this is a node A, okay, and this is a node B. So the voltage difference between node A and B is 24 volt. Okay, so we can calculate current through this 24 ohm resistance. Suppose this current is I1, and we can also calculate the current through resistance 8 ohm. So this is suppose I2. So the voltage difference between these two nodes is 24 volt. The resistance is 24 ohms. Then from Ohm's law we can write that the I1 equals to 24 volt divided by 24 ohms. That means it will be 1 ampere. So this current is 1 ampere. And this resistance also, the difference between the voltage difference between this 8 ohm resistance also 24 volt, because these are two are parallel. These two resistance are in parallel. That's why this resistance, that means 8 ohm resistance, also feel the same voltage. So I2 will be 24 divided by 8. So it will be 3 ampere. 3 ampere. So suppose the current from this voltage source is I. Then applying KCL at node A, we can write that the incoming current is I and outgoing current is I1 plus I2. So the current is I1 will be 1 plus 3, that means 4 ampere. So I equals to 4 ampere, and this is 1 ampere and this is 3 ampere. Okay, you have to calculate the value of resistance R. So if I take, this is a one mesh, this is a mesh number 1, mesh number 1. So if I applying KVL at mesh 1, so current will flowing in this direction. So it will be positive, negative, this is positive, negative, this is negative, positive. So if I start from this portion, so it will be current multiplied by resistance plus, this is plus minus, this is plus minus, this is a 24 voltage, 24 minus 200 equals to 0. So this is plus minus plus minus minus plus, that's why the negative signs comes here. So from this equation we can write that 4R equals to 200 minus 24. So it will be 6, 7, 1. So R will be 176 divided by 4. So it will be 4 ohm. So the value of resistance R will be 44 ohms. So this is problem. In this way you can solve this problem. Now the next one. What is the next one? Suppose this is 1. Problem number 1. Here you have to calculate. This is a 120 ohm, this is 60 ohm, this is 200 volt, this is 220 volt, this is 220 volt, this is 200 volt, and this is the resistance 30 ohm. So you have to calculate the current through this resistance 30 ohm. You have to calculate the resistance of the 30 ohm resistance, current through 30 ohm resistance. How to calculate this current through this resistance? You have to know the node voltage. Suppose this is a node, okay, this is suppose node A, this is suppose node A, and this is a node B, this is node B. So if I able to calculate the node voltage of node A, then I can easily calculate the current through this resistance 30 ohms. Okay, so suppose the node voltage at A equals to VA, and all currents are leaving. I assume that all currents are leaving from this node. Okay, I assume that all current are leaving from this node. So node voltage will be maximum. So applying KCL at node A. So this will be VA. Current through this branch will be VA minus 200 volt minus 220 volt divided by 120. How to calculate this? This node voltage is greater than this. I assume that. That's why the current through this branch will be VA minus 200 minus 220 divided by 120. Plus current through this node, through this branch will be VA minus 220 minus 200 divided by 60, and current through this branch will be VA divided by 30. It will be 0. This is the KCL equation of node current, node A. Now we have to solve it. So, or you can write that this will be 120. So this is VA, and I add this, so it will be 420. It will be 420 and this will be 2 VA, and this will be 440 minus 400. It will be plus 4 VA equals to 0. So this is a VA, this is a VA, this is a VA. So 3 and 7. So it will be 8 VA. 7 VA. 7 VA. And if I add all these values, then it will be 0, 6, and 4, 12 divided by 120 equals to 0, or it will be 7 VA equals to this. Okay, so or VA will be 1260 divided by 7, so it will be 180. Okay, so this is the node voltage. This, so if I know this node voltage, then I can easily calculate the current through this branch of consisting 30 ohm resistance. So current through this branch I equals to VA divided by 30. So VA is 180, so this is 30, so it will be 6 ampere. So current through this 30 ohm resistance is 6 ampere. Okay, so I have solved the problem number 1. Now problem number 2. What is the problem number 2? This is the 3 voltage source, DC voltage source. This is 2 ohm resistance. The current through this resistance is I, and this is the current source I by 3. This is a current source I by 3. This is a 3 ohm resistance. You have to calculate this is not current, voltage across. You have to calculate voltage across 3 ohm resistance. Okay, so you have to calculate the voltage across this 3 ohm resistance. So how to calculate this? First of all, we should calculate the current through this junction 3 ohm resistance. Okay, so suppose this is a node A. Okay, this is a node A, and I assume that the current, all the current will flowing in this direction. So this is I by 3, this is I by 3, and this is, suppose this is Ix. Okay, so applying KCL at node A. The incoming current is I, and outgoing current is I by 3 plus I by 3 plus Ix. Okay, I assume that this current is Ix. So from this equation we can easily calculate the value of Ix, or Ix equals to I minus I by 3 plus I by 3. So it will be I by 3. So current through this resistance 3 ohm is I by 3. So this is a mesh, this is a mesh. So suppose this is a mesh 1. So if I applying KVL at mesh 1, then we get current flowing this direction. This is plus minus, this will be plus minus, this is all are minus plus minus plus minus plus. So if I start from this here, from here, so it will be resistance multiplied by current plus resistance multiplied by current minus 3 minus 3 minus 3 equals to 0. So this is the KVL at mesh 1. So from this equation we can calculate the current I. So it will be 3 will be cancel out, so it will be 3I minus 9 equals to 0. So I equals to 9 by 3 equals to 3 ampere. Okay, so value of I have calculated. Now voltage across 3 ohm resistance. So voltage across 3 ohm resistance equals to I into R. This is I, this is R. So value of I is given by 3. So 3 by 3 multiplied by 3. So it will be 3 volt. Okay. So the voltage across 3 ohm resistance is 3 volt. So this is the problem number 2. So in this way you can solve this problem using KCL and KVL. Now problem number 3. Problem number 3 is a different types of problem. Here you see that this is a 5 volt DC source, this is 5 ampere, this is 10 amperes, these are two are in parallel and there is a current source 0.5 ampere. So you have to calculate the total resistance faced by this voltage source which have internal resistance is 0. This is voltage source have internal resistance equals to 0. So you have to calculate the resistance faced by this voltage source. Okay, so how to calculate this? If I able to calculate this current I from this voltage source, then the resistance will be V by I. This is the 5 by I equals to 5 by I. So first of all we should calculate the current I from this network. So if I take, this is a node, this is a node A, this is a node A. Okay, so current will passing through in this direction, this will be in this direction and in this direction. So current through 5 ohm resistance will be in this direction and the current through 10 ohm resistance will be in this direction. So if I apply the KCL at node A, so you have to take the node voltage, suppose VA, node voltage suppose VA. So applying KCL at node A. Now this is a 5 volt source and this is a node voltage. So there is no resistance in this region. So the node voltage will be 5 volt because there is no resistance between this node and 5 volt resistance. That's why this point and these points are same. That's why the node voltage of node A will be 5 volt. So here is the node voltage VA equals to 5 volt. Okay, because there is no resistance between this node and the DC source. So we can write that VA divided by 5 current through this junction plus current through this junction is VA divided by 10 and current through this junction is 0.5 ampere. This is 0.5 ampere. So this is the KCL at node A. Equals to this is the incoming current I. Okay, so current through this resistance is VA by 5, current through this resistance is VA by 10, current through this branch is 0.5 ampere equals to the incoming current I. So this is the I. Okay, or the value of node voltage VA is 5, so 5 divided by 5 plus 5 divided by 10 plus 0.5 equals to I. So it will be 1 plus 0.5 plus 0.5 equals to I. So it will be 2 ampere. So value of I will be 2 ampere. So the voltage, the resistance faced by voltage source equals to V by I, not R. The value of V is 5 volt and value of I is 2 ampere. Value of I is 2 ampere. So it will be 2.5 ohms. So this is the problem number 3. So